my name is SpongeBob SquarePants and I am here representing Rope 6. Today we are going to talk about JVM. To begin with, we are going to look at what the Java Virtual Machine is and how it works. Later on, we are going to look at the positive and negative aspects of the JVM and its components. So, what even is a Java Virtual Machine? A virtual machine functions as a non-physical operating system equipped with its own memory, storage, CPU, etc. Operative systems run instructions from different programming languages in dissimilar or even incompatible ways. Languages such as C and C++ have their compiled to machine code in order for the operative system to execute the code. However, other languages such as JavaScript and Python don't need to be compiled but are rather interpreted by another system. Java uses both these concepts by compiling a program into bytecode. Java Virtual Machine, or JVM for short, is also a virtual machine which allows for Java's bytecode to be translated into machine code for a given processor. JVM, therefore, enables Java programs to be run on different CPUs without having to rewrite or edit code.
SpongeBob, give me the mic. Hi, Cam. Java Virtual Machine can be split into three main functions: the class loader, runtime data area, and the execution engine. The class loaders, the subsystem of JVM which transports and saves files to the operating system's RAM, where the JVM is located. Moreover, the class loader can be further divided into three parts which include loading, linking, and initialization. The loading part deals with saving class files to the JVM with necessary information such as the type, interface, and hierarchical structures. The second step of the class loader is the linking process. This process is again split into three steps: verification, preparation, and resolution. The verification step confirms that the class files that were set come from a valid, compatible compiler, and that the code has a proper format and structure. The preparation process allocates memory to all static variables and assigns default values to them.
Squidward, can I speak now?
Ah, shut up. Finally, the resolution step provides the different variables, methods, standard local address where can be accessed by the JVM layer. This is a necessary step since the operative system can't access variables through names given as strings. The final part of the class loader, the initialization phase. As mentioned earlier, when the class file is received by the JVM, all static variables are given a default value. It is up to the initialization phase to set the correct values for the various variables, as declared the program itself.
Squidward, are you okay? SpongeBob, I think you broke him. Game. Next up is the second part of the JVM, the runtime data area. Runtime data area is divided into method area, area stack, area, PC registers, and native method stacks. All the information in the class like class name, third class name, methods, variables, etc. is stored in the method array. There is only one method array per JVM. Java heap area is the memory areas to store objects instantiated by programs running in JVM. Stack area is a part of the memory which stores local methods, local variables, reference variables. Program counter, also known as PC registers, or registers in the JVM, that holds the address and memory of the current executing instruction for each thread. It will update to the next instruction once the executing instruction completes. Native method stacks hold information on native methods. Native methods are methods written in other languages than Java, C or C++. This lets JVM implement Java native code.
Money, money, money! Give me the mic! The final part of the JVM is the execution engine. The execution engine is split into three parts: interpreter, just-in-time compiler, and garbage collector. The interpreter is the part of the execution engine that reads a Java bytecode and converts it into machine code, which then runs the program in the CPU. The just-in-time compiler, or JET for short, is the part of the JVM which optimizes a program's performance. The just-in-time aspect derives from the fact that the bytecode is translated to machine code when the program is run. In short, the interpreter and JIT work together to translate and optimize programs that the JVM receives. The interpreter translates the bytecode into machine code line by line, while the JIT compiler takes bytecode during runtime and converts it to native machine code. Since the JIT compiler works during runtime, the performance of the program is enhanced. The last part of the execution engine is the garbage collector. Throughout a program's runtime, there will be objects, and such that are no longer in use. If these parts of the program are kept in memory, the program will grow less efficient as time passes. It is, therefore, the garbage collector's job to remove these objects. Overall, this part of the execution engine improves the performance speed of a program, and that means more money. Ha ha!
Mr. Krabs, you only think about money.
Life is about fun, not money.
Shut up, you kids. Money, money, money!
No, now it's my turn to talk. Ahem. So now we have looked through the JVM. The class loader brings class files into the ROM. The bytecode is verified for any security breaches using the runtime data. And then the execution engine converts the bytecode into native machine code. The question now is, what are the advantages and disadvantages of the Java virtual machine? I'll tell you. One of the advantages of JVM is that Java bytecode can be written once in one program and then run on any platform. The bytecode doesn't need to be ported to a specific hardware environment because it runs in the Java virtual machine, which can be run on any computing platform that has Java. Another advantage is that Java was written as a secure platform. The Java virtual machine has a built-in security that allows programmers to write highly secure Java programs. Moreover, through specs such as the just-in-time compiler, JVMX to optimize the runtime performance of programs.
Give me the mic, SpongeBob. I'll tell you the bad sides. Although JVM attempts to optimize programs, it's comparatively slower than some equivalent programs written in C++. For example, the GIT compiler also needs a lot of cache memory to operate, which increases the time complexity of the program. Another disadvantage is that the JVM compiler has to compile source code, while smaller programs take insignificant amounts of time to compile. Larger projects can take significantly more time. The time spent waiting for a program to compile can be a waste. This waste stacks over time as debugging and functionality tests are performed, where compiling has to be done every time. Thank you for watching.
Thank you for watching.
Thank you for watching.
Thank you for watching. Money, money, money!